this question, we want to find all the A, B, C, D, obviously all that four possibilities for that fourth vector there, so that this set of four vectors is orthogonal. It's probably worth it to just make sure that the pairs that we can make from the first three vectors are orthogonal. So if I take the 1, 0, negative 1, 1 and dot it with any other combination, we do get 2 plus 0 minus 1 minus 1 is 0. So that's good. And just make sure they all work out before we go through any further, in case the answer is it's not possible. Oh, I already have that one. 1, negative 3, 1, 0. So it's 1 plus 0 minus 1 plus 0. And then the other combo we can make are the second and the third. And so 2 minus 3 plus 1 plus 0, and that's also 0. So the first three, if we had them on their own, that set would be orthogonal. And we just want to find a fourth one to make this orthogonal basis in R4. So basically, yeah, we need all of these other dot products to also work out. So I need 1, 0, negative 1, 1 dotted with A, B, C, D to be equal to 0, which means that I need A minus C plus D equal to 0. And then I need the other one, 2, 1, 1, negative 1, dotted with A, B, C, D to be equal to 0. And so I need 2A plus B plus C minus D to be equal to 0. And then finally, I need the other pair, 1, negative 3, 1, and 0 dotted with A, B, C, D to be equal to 0. And so I need A plus 3B, minus 3B plus C to be equal to 0. And so what we actually get is a homogeneous system of equations. So we can put this into a matrix equation now. So I'll have 1, 0, negative 1, 1, 0 down the side, 2, 1, 1, negative 1, and 1, negative 1, 1, and 0. And yes, so we're going to go ahead and solve this system of equations. Of course, that's not a minus 1 there. That's a minus 3, so I'll fix that so it actually matches that third equation. So yes, we'll just go ahead and solve this. I'm going to get this into a nicer form here. So I'm going to subtract 2 of the first row from the second to get 1, 3, negative 3, and 0. And then I'm going to subtract the first row from the third to get 2, yes, negative 3, 2, and negative 1. And then I'm going to add 3 of the second row to the third. And so this should give us our echelon form. So we can see I've got my 3 pivots here, here, and here. So I do have a free variable, if you recall. And so just to avoid some fractions here, because I know that if I solve that fourth equation, I've got an 11 out front of the third term, in front of the C column. So what I'm going to do is actually let D be 11t, so that when I actually divide out that 11, it's going to leave me with an integer. It's going to be a little bit nicer. So basically what this equation here says is 11c minus 10 of that, so minus 110t equals 0. So c is 10t. And then working my way back, this equation here says b plus 3 times the c, so plus 30t, and then minus 3 times d, so minus 33t is 0. And that's going to give me b is 3t, and then a minus c, so minus 10t, plus d is 0, and that's going to give me that a is negative t. And that is actually going to be my combination. So A, B, C, D equals some t times -1, 3, 10, and 11. And you should be able to go ahead and check, this is our answer, but you should be able to go ahead and check that if you do the dot product of this -1, 3, 10, 11 vector with any of the three original vectors, you will get 0. So it is orthogonal to each of those.